So any question? The same. Junting, okay for you? Likewise, Panka, okay for you? About the results, assignment 3 asks you to have the plot. Assignment 2 asks you have a table. Assignment 1 asks you to have a figure. So only 1 and 3, you need to have a plot. So any question else? Assignment number 1, because you need to have the confidence interval. I just answered the Jenkins question. Assignment number 1, we need to have the confidence interval. So confidence interval. So you just follow the way of calculation in chapter 4. And chapter 4 asks you to have the sample size. If you need to have the result, maybe you follow my instruction. Select sample size to 10. All right, so imagine if you run M1 queuing system, and for a point 0.2, you will have a point here, but we need to have an interval. How to have an interval? The interval needs to have the sample size, so you need to run simulation 10 times. For the 10 times, you should have the different value. It doesn't mean you need to have the same seed. So that's why for each time of a simulation, you need to select different random seed. Well, to alter the random seed, you need to alter random seed by using LCG random. Right? And then you can have 10 different values. Or otherwise, you always have the same value for the 10 simulation runs. That is not okay at all. So that's why I let you know, try to check LCG random where to set the different random seed. One way to have the different random seed, you can use time. System time. Modify system time to have the random seed. And then you can achieve this way to have the different random seeds. I think this is some more details if you want to have random seeds. And so that you have the 10 different simulation runs. And so that you can have the confidence interval for a corresponding point. You can try to repeat for second point, third point, and the fourth point. Or maybe simultaneously, you can have a set of the 4 points, but you need to run 10 times of the simulation. And that's it. So understand me? No, randomly, it is not a stream. You can try to use different streams. But this one, you should use many streams. Still okay, but you can try to switch stream 1, 2, 3 to 10 and run all the points here. That way is okay as well. Okay, so random seed using the same stream, but different seeds. If you don't want to use random seed, you can have the same initial random seed. You can try different streams. And then you will have the same way, maybe not the same, similar way to have the confidence interval. Either one is okay for you. About this, you guys okay for the way to have confidence intervals? Is it okay for you? Junting, okay for you right now? Okay, so random seed, actually you need to know how to alter the random seed. So you need to check the LCG random. And if you don't want to check all the details, you can pick 10 values of streams so that you have value string 1, string 2 to string 10. Serve us the 10 simulation result. And so that the 10 simulation result allow you to calculate the confidence interval. And that's it. So let me get the feedback from you guys. If it doesn't mean 10. 10 too small. 10 too small. So think about this. 10 simulation runs. Each run, for example, collect 1,000 samples. Maybe not sample. Sample size. Oh, wait a moment. Ten simulation runs. Okay, for each simulation. For example, you can use 10,000 number of customers. Delayed. I use a way here. Maybe can tell you 10, not the same as a row of 10,000. Up to now, understand me? Jinting, you understand me? So later I will re-explain. Yeah, maybe about confidence interval, we have a sample size 10, but wrong simulation, sample size indicate times of a simulation. So that's why Andrew is correct. 10 times of a simulation. Each simulation contains 10,000 samples for that mean. That's it. So Andrew copy my idea. That's correct. Understand me. So that's correct for Andrew. If you have 3 points, then it says each one 10 times. So you need to have 30 times of a simulation. That's correct. So Andrew, okay for you? All right. Thank you for your feedback. And Jinting, okay for you? All right, so I use this one to illustrate why 10 means simulation runs 10 times. This one, ten observations. This is so-called n equal to 10. Maybe you have these from individual simulation runs, right? So from different simulation runs. So that's why you need to have different simulation runs. And of course, if you want to have a one-time simulation run, but 10 streams, that's okay as well. Here, I just mean each time you have one stream, repeat 10 times, and then you have 10 simulation runs. If you don't want to repeat the simulation run, allow all stream to have the 10 collections. That's fine. That's okay for you too. All right, so about this way, Jinting, okay for you? So because of this, that is the point. Okay, so maybe I assume each time occupy one simulation stream. So then you need to use 10 times of a simulation run. Of course, you can use one simulation run but cover 10 different values of streams. And so that you can have the 10 different observations, and that's okay for you too. But normally we should alter the random seed rather than the streams. If you want to make it easy, you can have 10 simulation streams and still can reach the same goal. And that's all. All right, so up to now, I think you guys should totally understand, right? So let me make sure, Jinting, Any other question? Junting, okay for you? Okay. And Andrew, okay for you? And Panka, okay for you? So let me wait the feedback from Andrew. And Diego, okay for you? So Andrew have the comment. Let me check the comment. For arrival rates. Oh, for arrival means 4 different arrival rates. If I assume each time you run 1 point, so you need to have 4 times. However, the same, you can have the setting for 4 rates in a simulation. So you can have the change. Okay, so any combination is acceptable. You can have one simulation run to have the 4 rates and to have the 10 streams. And then only one single simulation run. And actually, if you consider each one as one simulation run, so you need to run 10 times multiplied rates, so 40. And that's all. So, okay for you, Andrew? So again, let me wait the feedback from Andrew. About the service rate, if I want to alter, sure. But I should really have the suggested service rate. You see? So problem assignment 1, fix. Fix. So no choice. O are 1. That's all. So you are not allowed to have a 0.001. So okay for you, Andrew? All right, so I think almost all. This is a discussion about programming assignment number 2. So I think right now you guys should understand how to have, actually at least you know the meaning of the assignments. So I think right now you should understand how to do. And just take your time. And if you can finish in a week, sure, no problem. If you still cannot finish within here, today to next Tuesday, you cannot finish, I allow you to have one more extension if anyone asks me to have the extension. And that's all. This is information about programming assignment number 2. Okay for you guys, right? All right, so let me switch back to the discussion for chapter 6. For this one, we do not use a heuristic approach. We use a test. All right, so we use test. So we should use test to check acceptable or not. All right. All right, so how to do? For example, we have the hypothesis, observation data, sure. And we have the fitted one. All right. And how to reject, accept the fitted one or to reject the fitted one. Okay, so in fact, we should have the idea. The idea actually that you have the following tests, but we only focus on some of them. For example, chi-square test. As for the others, the same in the test book. In the test book, you guys can check. So that'll check chi-square. Chi-square need to have the interval. Okay, and sometimes the interval not necessarily of equal width. So this one you should understand first. At this, you need to define the intervals. All right. If we have the interval, look at this. You may have the observation n sub j in j's interval. And next one, something like the previous discussion, we should have the corresponding probability. Okay, so how to have the corresponding probability? If you have the continuous one, using the interval through integral, or if you have the discrete one, collect the possible points, the probability for the possible points. And then you have the multiplication, and multiply those results. The first one, observe. The second one, expected one. We try to find the difference. Okay, and of course, if we have the perfect match, this one approach 0. However, things not like that, so we should have some difference for sure. And raise the power to 2 and over mean. Okay, and get the sum. This is called the chi-square, statistic of the chi-square. And chi-square, the methodology of a chi-square allow you to have this. Using the chi-square distribution and try to find the level of test. And degree of freedom is k minus 1. Okay, and you can find the critical value. If the statistic chi-square greater than the upper critical value, then we need to reject, or otherwise we accept. All right, so this is the story of the chi-square test. Using chi-square test, of course, seems to be general and actually asymptotically valid. However, about the drawback, you may have many intervals. So different interval perhaps alter the conclusion. All right, and maybe you need to have some possible value, for example, this. Okay. However, at this we can use, so we don't care about too much about this. So how to do? This is a way to check this. I think about the test previously you've known, but it just says here you have the way to find the critical values. Of course, you need to have the suitable table to have the critical value. So in the following, we follow the previous example, exponential one, but we have a special selection for the interval. Look at this, K, and define different interval to have the same probability. As for how to do, it asks you to look at the task for why and how they can achieve this. If they can achieve this same probability, so really easy to find this point, but maybe not really easy to find n sub j, right? And also through the table, you can have these. And actually, critical level, this one, lower than, so do not reject, accept. Okay. Right now, maybe you still need to refer to the data. And actually, it seems to be no data, but previously, I didn't know in the task book, you can have the data. So you need to pass on the data to have the calculation, right? And also one technique, the same probability. So that the interval, so you need to count any points fall within the interval, and so that you have the relative frequency n, capital N sub j. And likewise, you can try the second example. But second example, you have a K here. You can have these. Okay, and you have the statistic and critical point. And the same, do not accept, so accept. Sorry, do not reject, so you accept. Okay, so this is a way if you have the test. Using test, it's really direct. Accept or reject, you will have a suggestion. It doesn't mean about the heuristic. You will feel you choose it or you do not choose it. So you may have some possible room to select or reject. But right now, if you fix all the values, the test that you have the direct result, accept or reject. And that's it. This is a test. And I think you can follow. Actually, this is a table from the task book. You can follow the way to have the interval. And so that you have these. And so that you have all of these. And you can check, is it true? And actually, you should find a critical point of a chi-square. Let me check where you have the table. Wait a moment. Appendix, on appendix, table T.2. Here you have the chi-square distribution with the degree of freedom nu. Okay, so you can try that one, and so that you have the critical point. Let me take a picture for you guys, then you can use it. So that one, so that you have the way to look up, and so that you have the critical point for chi-square. That's it. Oh, sorry. Uh, let me continue. This one just illustrates how to have the detailed calculation, right? So you just follow the way to have the results. And this is the second example. And that's all. As for the KS test, I skip it. You just follow the current description here. AD test, the same, I skip it. And Poisson test, the same, I skip it. So you just follow the way to have the results. Actually, the task will provide you the software. As I remember, the software accompanied with the taskful. I'm not so sure you have it or not. It is called the ExpertFit, and you can use it for the calculation. You see? It says it is a commercial version. All right, and you can use the ExpertFit to have some of these. Okay, so you can check the hyperlink, and then you can find the ExpertFit, so that allow you to have an easier way to build some of the results. Okay, so maybe some of further illustration. For example, these. You see, they may have the way to generate all of these. So you guys can try. All right, but for me, I just illustrate. Someone provide you. I just illustrate someone provide you this software, so you can try. Okay, look at this. You can download from this one. So I think if you want to use it, you can download ExpertFit. If you want to have the calculation for yourself, I think you can try for yourself. So you can have a try. If you like it, of course, you will continue to use it. If you don't like it, maybe you will have your own way to have it. Okay, so I just let you know, I do not illustrate how to do, so you should download and then check how to use it. And next time, we will continue for the remaining discussion. And of course, for the remaining discussion, perhaps for some of the parts I may skip. It doesn't mean I don't have time, so I skip. In the past, the same. For some of the results, I think maybe right now we do not use them directly, so I skip. If next time you need to use it, perhaps you can get back to those parts and try to make sure how to use it. For example, about the test, if someone asks you to have a PP test, to have a AD test, to have the other test, I think you guys can try. All right, that's all. This is the discussion for all of these. And next time, we will start since this page. 121. All right, so up to now, any questions? If no, that's all. And see you next week. And also, if you understand you can try to have the homework, the programming assignment next Tuesday. If you still need to have more time, you can request the extension. That's it. Any questions? If no, see you next week. Bye-bye.